Welcome back to another lesson in MCV4U. Today we'll be talking about the derivative of y is equal to tan x. Last lesson we spoke a little bit about the derivatives of the other trigonometric functions of sine x and cos x, and so today we'll be continuing on with this idea and looking at y is equal to tan x. So let's look at this warm-up questions. And it says differentiate and do not simplify the derivative. And the hint here says consider how to manipulate the original function so that you can most effectively take the derivative. So here we have y is equal to 2 cosecant square root x squared plus 1. And here we understand that cosecant is 1 over sine. So 1 over sine. And so here we can rewrite this as 2 sine square root x squared plus 1 to the power of -1. And so once we have simplified a little bit here, then we can find our derivative. So remember, we do our outside, so we bring the -1 down. So we have -2 sine square root x squared plus 1 to the power of -2. And then we have to find the derivative of the inside. So remember that the derivative of sine is cos, and then we have square root x squared plus 1. And then we have to find the derivative of the inside of that. So remember, the square root, the derivative of the square root is 1 over 2 square root, whatever values are underneath. So here it would be 2x squared plus 1. And then the derivative of the inside of the square root, which is 2x. And here we can cancel out the 2 that's in front of the square root x squared plus 1, and then in front of the 2x. Okay, so here, continuing on, we have y prime is equal to -2 cos square root x squared plus 1 over sine square root x squared plus 1 to the power of 2. So just moving the negative exponent to the denominator, multiplied by x over square root x squared plus 1. And here, I can simply rewrite this as y prime is equal to -2. So -2x over square root x squared plus 1. And here you can see that there's cos over sine square root x squared plus 1 squared. So there's 2 sine square root x squared plus 1. So cos over sine, we know that that can be simplified to cotangent square root x squared plus 1. So here we'll just write on the side cos x over sine x is equal to cotangent x. And here we see that we have 1 over, we're left with 1 over the sine x, and we know that 1 over sine x, in this situation, the x is square root x squared plus 1, but the same idea, we know that that would be cosecant x. So here we can simplify the rest of that to multiply by cosecant square root x squared plus 1. Okay, so here we have y is equal to secant x times sine squared x. So here, remember, secant x, that is 1, let's write that here, secant x is equal to 1 over cos x. in this situation, we're going to write it as cos of -1. So here we have, you can rewrite this as cos of -1 x times sine squared x. So here we're going to use the product rule. So here we have y prime is equal to cos, so, so to move the -1 down, so negative cos -2x times the inside, which is again the cos x, so that would be negative sine x. And then we keep the b in the situation, which is sine squared x, so times sine squared x plus, so we're keeping the cos -1, so that would be our a, and then our b prime, bring the 2 down. So we have 2 sine x times the derivative of the inside, which is cos x. So here, our cos -1x and our cos x will cancel out. So here, we can simplify it. So here we have y prime. So let's just rewrite this actually here. So here we have y prime is equal to tangent squared x times sine x plus 2 sine x. And so if you recall, again, here we'll write on the right-hand side, remember tangent x is equal to cos x over, sorry, is equal to, sorry, is equal to sine x over cos x. And so in this situation, we see that we had sine squared x over cos squared x. If we rewrite that, which will give us tangent squared x, and then we have our sine x, the negatives make all of this positive, plus 2 sine x. So here, if we take out a common factor of sine x, we'd be left with tangent squared x plus 2. Okay, and let's look at this. So here cos x. So remember, to simplify first, we have cos x. We know that tangent x is sine x over cos x. So we know here that cos x will cancel out. So we're just finding the derivative of sine x, which we know is equal to cos x. So again, that's why you want to try to simplify as much as possible first before finding the derivative. So here it says determine d to the power of 71y over dx to the power of 71 for the function y is equal to cos x over 2. Okay, so here, if we start off with ey over dx, so our first derivative, that will be equal to -1 over 2 sine x over 2. Okay, so that's the first one here. Second, if we find our second derivative, so, so d squared y, or the second derivative, dx squared, is equal, so do the derivative again, we get negative 1 over 4 cos x over 2. Okay, for the third derivative here, we get third derivative is equal to positive now 1 over 8 sine x over 2. Fourth derivative here, again, it's positive 1 over 16 cos x over 2. Okay, so a couple of things that we can notice here is that when we have an odd function, we know that it's going to be sine x over 2. When we have an even function, or an even, when we're deriving an even one here, again, it's going to be cos x over 2. Here we see that the coefficient is always, the coefficient is always 1 over 2 to the power of n. So whichever derivative we're on, so again, for the first derivative, the coefficient is 1 over 2. And then here, again, for the second derivative, 1 over 2 to the power 2. So 1 over 4. And here we see that the sign for every fourth, again, will repeat. So here we see that, again, if we look at our fifth derivative here, see that comes negative 1 over 32 sine x over 2. So if we're looking at the 71st derivative, so here we'll just write sine for every fourth repeats. And so here we can see if we take 71 and divide that by 4, give us 17, and that's about the third one there as well, because we get a value of 17.75, which means that it would be the third out of the fourth in terms of its cycle. So here we can write, that means if it's the third out of the fourth cycle, we know that that's going to be positive. So here we can write the derivative, 71st derivative of this function is equal to positive 1 over 2 to the power n. So in this situation, it's 71. And then here, because it's the third out of the fourth it would be sine x over 2 because it's an odd as well. Okay, let's take a look at these additional ones there. So here we see that if f of x is equal to tangent x, then here f prime of x is equal to secant squared x. So here, if f of x is equal to f of x is equal to tangent c of x, then f prime of x will be equal to secant squared g of x, and then multiplied by g prime of x. And so here, if we look at the proof, so here we see that f of x is equal to tangent x, and we can rewrite tangent x as sine x over cos x. Remember here we can use quotient rule. So if we use quotient rule, f prime of x is equal to cos x times cos x minus sine x times negative sine x over cos squared x. So here f prime of x will be equal to cos squared x plus sine squared x over cos squared x. Remember here, now the trigonometric identities. Remember cos squared x plus sine squared x is equal to 1. And so here we see that 1 over that's equal to 1 over cos squared x, which we can also rewrite as secant squared x. Okay, so let's look at a couple of these examples here. Here we have to differentiate and simplify the following functions. So here we have y is equal to tangent 3x squared minus 2x. So again, the tangent in this situation is considered the outside, and the 3x squared minus 2x would be the inside. So again, derive the outside, then the inside. So y prime is equal. So remember, we just learned that the derivative of tangent is secant squared. So secant squared g of x, in this situation, it's 3x squared minus 2x. Then the derivative of g of x, or 3x squared minus 2x, which is 6x minus 2. Here we have x squared times tangent 2x. Here we have a and b. So here we're going to use, again, the product rule. So y prime is equal to a prime b plus a b prime. So here y prime is equal to the derivative of a, which is 2x, times b, is tangent 2x, plus a by itself, which is just x squared. And then we have tangent 2x, so we have secant squared x, and then the derivative, sorry, secant squared 2x, and then the derivative of the inside, which is 2. So here, if we take out 2x as a common factor, we'll be left with tangent 2x plus x secant squared 2x. Okay, let's continue on. So here for c, we have tangent bracket 3 to the power of x minus 4x. So again, outside first. So secant squared 3 to the power of x minus 4x, and then the derivative of the inside. So 3 to the power of x times ln 3 minus 4 is the derivative of the inside. And for d here, we have tangent power 3 e to the power of square root x. Okay, so we're going to have to here, again, first thing, this will be these two different colors. So derive this first. So just label it. So this is A, and then we'll derive tangent, which is B, derive the entire e to the power of square root x, which is C, and then we'll derive square root x, which will be D. So here we have, so we have y prime, we'll have to derive A prime, B prime, so A, so let's do times B prime times C prime times D prime. Okay, so let's do that over here. So here we see that y prime, so let's do A prime first. So here we move the 3 down, we have 3 tangent n minus 1, so tangent squared e to the power of square root x multiplied by the derivative of b, so derivative of tangent, which is secant squared e to the power of square root x. And then for c, the derivative of e to the power of square root x is just e to the power of square root x. And then the derivative of square root x is 1 over 2 square root x. Okay, so let's keep going. So here we have y is equal to 3 cos 5x times tangent 5x. So here, let's see if we can simplify this first before doing the derivative. So 3 cos 5x times sine 5x over cos 5x. So here we see we can cancel out the cos 5x. So here we'll just be left with y is equal to 3 sine 5x. And that would be an easier derivative here. So here we'll get 3 cos 5x times the derivative of the inside, which is 5. So y prime is equal to 15 cos 5x. And here we have sine 3x over tan 2x. And so here we're going to have to use the quotient rule. So use the quotient rule. So y prime is equal. So here, let's just label this as A, this as B. Here, y prime is equal to A prime B minus a b prime over b squared. Okay, so here in this situation, we have the derivative of sine 3x first, which is a. So here we'll have 3 cos 3x times b, which is just tangent 2x, minus a, which is just sine 3x, times b prime, so secant squared 2x times 2. That's all over b squared, so tangent squared 2x. So let's look at this example number 2 here. It says find the equation of the normal to the curve y is equal to 2x minus tan x at the point where when x is equal to pi over 4. So remember, normal just means that it is the line perpendicular to the tangent. And here we know that the slope of the normal is equal to the negative reciprocal, so -1 over the slope of the tangent. And so here, again, we're trying to find y is equal to mx plus b. And our point, we have 1 at x pi over 4, but we don't know our y value. So here, the first thing we'll do is we'll sub it into our original equation of 2x minus tangent x, and we'll sub in x is equal to pi over 4 into that equation, which will give us y is equal to 2 times pi over 4 minus tangent pi over 4. It'll give us pi over 2 minus 1 over 2. And so y is equal to pi minus 2 over 2. It's our point will be at pi over 4 and pi minus 2 over 2. Okay, so let's find, again, our derivative here. So again, we have y prime is equal to 2 minus secant squared x. So again, the derivative of tangent x, remember, is secant squared x. So here we have y prime is equal to pi over 4. Oh, sorry, y prime at pi over 4. That's equal to 2 minus secant pi over 4 squared. Okay, so here, if you look at this, we know that, again, secant x is equal to 1 over cos x. So secant pi over 4 is also equal to 1 over cos pi over 4. You know that cos pi over 4 will give us 1 over square root 2. So here we have 1 divided by 1 over square root 2. And so that would be 1 times square root 2, which is equal to just square root 2. So here we can rewrite this as 2 minus square root 2 squared, which is just equal to 2 minus 2, which is equal to 0. So the slope of the tangent is equal to 0. It means that here the slope of the normal is equal to -1 over the slope of the tangent, which is equal to -1 over 0, which means that it is undefined. So here it's undefined, again, meaning that it's a vertical line passing through pi over 4. So therefore, x is equal to pi over 4.